There are essentially two ways to achieve an octet, and one of them is by adding a metal to a nonmetal. And so we know from general chemistry that metals have a low ionization energy. And so what that means is it's very energy. And so what that means, it's very easy for those electrons to give up. Sorry, it's easy for those atoms to give up electrons. And so if we look at an example, we have sodium, which is in column 1 of the periodic table, so it has 1 valence electron. If we add it to chlorine, which is in column 7 of the periodic table, and so what's going to happen is that sodium is actually going to transfer its electron to the chlorine. And so what we'll get now is a sodium without an electron, so it's going to have a positive charge, and a chlorine with 8 electrons around it. And so that's going to have a negative charge. And so the negative charge will be attracted to that positive charge. And so the chlorine achieves an octet because it has 8 electrons around it. And so what this is called is an ionic bond. And so that is the so it's an electrostatic interaction. And that just means that the negative charge is attracted via electrostatic forces to the positive charge. And so we talked earlier about achieving the octet and why it's an important goal. And so this chlorine achieves the electron configuration of argon, which is 3p6. And so that's a noble gas, which has a very stable electron configuration. So this chlorine is now happy. Now, the sodium is also happy because by giving up an electron, it achieves the electron configuration of helium, which is also a noble gas. And so it achieves stability. And so ionic bond is the transfer of electrons, and so it's unequal sharing of electrons. Now, the second way to achieve the octet is by adding a nonmetal with a nonmetal. And so we know that nonmetals have a high ionization energy. They don't want to give up electrons. They don't like giving up electrons. And so instead what they do, look at bromine as an example, and we'll add it to another bromine. So bromine is in column 7 of the periodic table, so it's going to have 7 valence electrons around it. And so these two, because they don't like to transfer electrons, they don't like giving up electrons, instead they will share their electrons. And so what we'll get is a bond being formed in which those 2 electrons are now being shared. And so this bond actually counts as 2 electrons for each of the atoms. So if we do the counting of the valence electrons, we'll have 2, 4, 6, and then that bond counts as 8 for that first bromine. So it achieves an octet. The second bromine, again, we'll do the counting. It has 2, 4, 6, and that bond would count as the 8 electrons it needs to achieve an octet. And so both these atoms are happy because both of them have octets. And so if we look at a covalent bond, and what that is, it is 2 electrons being shared within a bond. It's with each atom. So each atom will get essentially counted towards 2, or 2 counted towards it when counting their valence electrons. All right, and so let's recap the differences. So the ionic bond is the unequal sharing of electron via the electron transfer. And so the covalent bond is that 2 electrons are being shared, 1 contributed by each of the atoms. And then again, when we count, that bond goes towards each of those atoms bonded on either side. And so when we look at this, again, the goal is to achieve an octet. The goal is to get the electron configuration of noble gases. And so bromine does that by achieving a covalent bond and getting that octet. Now, there's one last way to get an octet, and that is by liking the video, commenting with your questions, and subscribing to the OChem Master on YouTube.